Carter circuit breakers are a type of electrical safety device used in the early days of electricity. They were invented by Charles Carter in 1881 and were widely used until the mid-20th century. Carter circuit breakers were typically wired in a series circuit. The line, or source, wire was connected to one terminal, and the load, or appliance, wire was connected to the other terminal. When the circuit was overloaded, the breaker would trip, breaking the circuit and preventing damage to the electrical system. Carter circuit breakers operated using the principle of electromagnetism. When current flowed through the breaker, an electromagnet was energized, creating a magnetic field. If the current exceeded a certain threshold, the magnetic field would become strong enough to overcome a spring and trip the breaker. Carter circuit breakers do share some similarities with Edison wiring, which was also used in the early days of electricity. Firstly, both used a series circuit wiring configuration. Secondly, both relied on fuses or circuit breakers to protect the electrical system from overloads. However, there are also some key differences between Carter circuit breakers and Edison wiring. Edison wiring used fuses for circuit protection, while Carter circuit breakers were designed to be reusable. Carter circuit breakers were typically rated for higher currents than Edison fuses, making them more suitable for modern electrical loads. Edison wiring was typically installed in knob and tube style, while Carter circuit breakers were mounted in panels. Carter circuit breakers are no longer used in modern electrical systems. If you encounter a panel with Carter circuit breakers, it is essential to have them replaced by a licensed electrician. These old devices may not provide adequate protection against electrical hazards and should be upgraded to ensure the safety of your home. Understanding the workings of a Carter circuit breaker requires grasping the fundamentals of electromagnetism and circuit protection. An electromagnet is essentially a coil of wire that generates a magnetic field when an electric current passes through it. The strength of this magnetic field is directly proportional to the amount of current flowing through the wire. In a Carter circuit breaker, this electromagnet is a crucial component. When the current flowing through the circuit is within the safe operating range, the magnetic field generated by the electromagnet is relatively weak. This weak magnetic field is not strong enough to overcome the force exerted by a spring mechanism within the breaker. The spring holds the breaker contacts in a closed position, allowing electricity to flow through the circuit and power the connected appliances or devices. However, when an overload occurs, meaning that the current exceeds the breaker's rated capacity, the situation changes dramatically. The increased current intensifies the magnetic field produced by the electromagnet. Once the magnetic field reaches a certain threshold, it becomes powerful enough to overcome the resistance of the spring. This causes the spring to release, which in turn triggers the breaker mechanism to trip. When the breaker trips, it physically separates the electrical contacts within the breaker, interrupting the flow of current through the circuit. This interruption is crucial because it prevents the excessive current from continuing to flow, which could lead to overheating, damage to wiring, or even a fire. The reusability of Carter circuit breakers was a significant advantage over fuses. Once a fuse blows, it needs to be physically replaced with a new fuse of the correct amperage rating. This can be inconvenient and requires having spare fuses on hand. In contrast, a Carter circuit breaker can be reset after it trips. To reset the breaker, you simply need to manually move the switch back to the on position. This reconnects the electrical contacts and restores the flow of current to the circuit. However, it is important to identify and correct the cause of the overload before resetting the breaker. If the overload condition persists, the breaker will simply trip again. The higher current ratings of Carter circuit breakers compared to Edison fuses also allowed them to handle larger electrical loads. Edison fuses were typically rated for lower amperages, which meant that they were more likely to blow if a modern appliance or device with a high power consumption was connected to the circuit. Carter circuit breakers, with their high current ratings, could accommodate these larger loads without tripping unnecessarily. The difference in installation methods between Edison wiring and Carter circuit breakers also reflects the evolution of electrical systems. Edison wiring, with its knob and tube construction, was an early method of wiring that involved running individual wires supported by ceramic knobs and tubes. This method was labor-intensive and offered limited protection against physical damage to the wires. Carter circuit breakers, on the other hand, were designed to be mounted in panels, which provided a more organized and protected way to distribute electricity throughout a building. Electrical panels offer several advantages over knob and tube wiring, including easier access for maintenance and repairs, better protection against physical damage, and the ability to accommodate more circuits. The fact that Carter circuit breakers are no longer used in modern electrical systems highlights the advancements in electrical safety technology. Modern circuit breakers offer a number of improvements over Carter circuit breakers, including faster response times, more precise overload detection, and better protection against arc faults. Arc faults are dangerous electrical discharges that can occur when insulation on wires becomes damaged or worn. These faults can generate intense heat and are a leading cause of electrical fires. Modern arc fault circuit interrupters, or RFCs, are designed to detect arc faults and quickly interrupt the circuit, preventing a fire from starting. If you encounter a panel with Carter circuit breakers in an older home, it is crucial to have them replaced by a licensed electrician. These old devices may not provide adequate protection against electrical hazards and may not meet current safety standards. A licensed electrician will be able to assess the condition of your electrical system, recommend appropriate upgrades, and ensure that the work is done safely and in compliance with local electrical codes. Upgrading to a modern electrical panel with new circuit breakers will provide you with better protection against electrical overloads, short circuits, and arc faults. It will also improve the overall safety and reliability of your electrical system. Replacing old Carter circuit breakers is an important step in ensuring the safety of your home and protecting your family from electrical hazards. It is an investment that can provide peace of mind and prevent potentially devastating consequences. When examining an old electrical panel with Carter circuit breakers, there are several key signs to look for that indicate the need for replacement. Firstly, check for any visible signs of damage or deterioration such as cracks, rust, or corrosion on the breakers or the panel itself. These signs suggest that the breakers may be compromised and unable to function properly. Secondly, pay attention to any unusual smells coming from the panel. A burning smell or the odor of ozone can indicate overheating or electrical arcing, which are serious safety hazards. Thirdly, listen for any buzzing or crackling sounds coming from the panel. These sounds can also indicate electrical arcing or loose connections, which can lead to fires. Fourthly, test the breakers to see if they trip easily or fail to trip at all when an overload condition is simulated. If the breakers are not functioning correctly, they may not provide adequate protection against electrical hazards. Fifthly, consider the age of the breakers and the panel. Carter circuit breakers are typically very old, and their components may have deteriorated over time. Even if the breakers appear to be in good condition, they may not meet current safety standards and should be replaced. Sixthly, if you are unsure about the condition of your electrical panel, it is always best to consult with a licensed electrician. An electrician can perform a thorough inspection of your electrical system and recommend any necessary repairs or upgrades. The process of replacing Carter circuit breakers typically involves several steps. Firstly, the electrician will disconnect the power to the panel to ensure safety. Secondly, they will carefully remove the old Carter circuit breakers from the panel. Thirdly, they will install new, modern circuit breakers that are compatible with your electrical system. Fourthly, they will connect the wiring to the new circuit breakers, ensuring that all connections are secure and properly insulated. Fifthly, they will test the new circuit breakers to ensure that they are functioning correctly. Sixthly, they will label the new circuit breakers so that you can easily identify which breaker controls which circuit. Seventhly, they will provide you with a certificate of compliance, which indicates that the work has been done in accordance with local electrical codes. The cost of replacing Carter circuit breakers can vary depending on several factors, including the size of your electrical panel, the number of breakers that need to be replaced, and the labor rates of the electrician. However, it is important to consider this as an investment in your safety and the safety of your home. The peace of mind that comes from knowing that your electrical system is up to date and functioning properly is well worth the cost. In addition to replacing Carter circuit breakers, there are several other steps you can take to improve the safety of your electrical system. Firstly, install ground fault circuit interrupters, or GFCIs, in areas where there is a risk of water exposure, such as bathrooms, kitchens, and outdoor outlets. GFCIs are designed to detect ground faults, which can occur when electricity leaks to ground. These faults can be dangerous and can cause electric shock. Secondly, install arc fault circuit interrupters, or RFCIs, to protect against arc faults. RFCIs are designed to detect arc faults, which are dangerous electrical discharges that can occur when insulation on wires becomes damaged or worn. Thirdly, use surge protectors to protect your electronic devices from power surges. Power surges can damage or destroy electronic devices, such as computers, televisions, and appliances. Fourthly, have your electrical system inspected regularly by a licensed electrician to identify any potential problems. An electrician can check for loose connections, damaged wiring, and other hazards that could lead to electrical problems. Fifthly, educate yourself about electrical safety and take precautions to prevent electrical accidents. Never overload circuits, use extension cords safely, and keep electrical appliances away from water. By taking these steps, you can significantly reduce the risk of electrical hazards in your home and protect yourself and your family from harm. The historical context of Carter circuit breakers provides valuable insight into the evolution of electrical safety technology. Charles Carter's invention in 1881 marked a significant step forward in protecting electrical systems from overloads and short circuits. Prior to the development of circuit breakers, fuses were the primary means of circuit protection. While fuses were effective at interrupting the flow of current during an overload, they had to be replaced after each event, which could be inconvenient and costly. Carter circuit breakers offered a reusable alternative, allowing users to simply reset the breaker after it tripped. This innovation not only improved convenience but also reduced the risk of using improperly sized fuses, which could compromise the safety of the electrical system. The widespread adoption of Carter circuit breakers in the late 19th and early 20th centuries demonstrates their effectiveness and reliability. They played a crucial role in the electrification of homes and businesses, enabling the safe and efficient use of electricity for lighting, heating, and other applications. However, as electrical technology advanced, Carter circuit breakers were eventually superseded by more sophisticated designs. Modern circuit breakers offer a number of improvements over their predecessors, including faster response times, more precise overload detection, and better protection against arc faults. Despite their obsolescence, Carter circuit breakers remain an important part of electrical history. They represent a significant milestone in the development of electrical safety technology and serve as a reminder of the ongoing efforts to improve the safety and reliability of electrical systems. In conclusion, understanding the history, operation, and limitations of Carter circuit breakers is essential for anyone working with or living in older homes with outdated electrical systems. Replacing these old devices with modern circuit breakers is crucial for ensuring the safety of your home and protecting your family from electrical hazards.